multiple rounds of simulations, basically. And what we found is that basically when we combine ctDNA together with the methylated ctDNA, it gives us a really, really good sensitivity and specificity. So it complements each other when we combine the multimodal approach. So we did a first validation using liver cancer. This is just using the ctDNA and also the methylated cfDNA combination to compare it with AFP, which is a common biomarker. And you can see that the multi-cancer early detection test is performing much better in terms of sensitivity and specificity compared to the conventional tumor markers. And we then roll out to look at a broader cancer using retrospective samples from biobanks, basically. And what we've shown here is that in general, overall, so the sensitivity of the test is about 83%, and then the specificity is well above 95%. And the more important thing is actually the positive predictive value and also the negative predictive value are very high, it's more than 90%. So this is something very important to look at. And even for the early stage, so if we look at overall performance, okay, when we compare the stage, okay, based on CEA, a tumor biomarkers, versus the multi-cancer early detection, at the very early stage, even 62%, you might think that is not good, but it is actually much, much better compared to the tumor markers that is available nowadays, which is hovering around 5 to 10%. And of course, as the tumor progress, so the blood tumor markers and the MSAT performance become quite equivalent. I think MSAT have its own value basically to detect cancer at the very, very early stage. Last year, we also worked together with Olink to publish a paper in Nature Communications, okay, to show that proteomics actually also play a role. I think moving forward, so the multimodal kind of analysis and also assay is going to be very important to improve the sensitivity and specificity of this test. Now, very quickly, okay, so to look at the other two questions, how we can actually achieve precision in the more affordable and also accessible way. So the answer to that is basically a comprehensive ctDNA profiling. So we have shown that, okay, as well as other places, is that, for example, lung cancer. Okay, the management of lung cancer currently, okay, if the patient is diagnosed, then they will do certain genetic tests, mainly EGFR. Then if they got the EGFR positive, then they will get the treatment. If it is negative, then they will follow up with other genetic tests. So it's a very sequential approach. So in average, it takes about 1.5 months from diagnosis to getting the right treatment. But if we can actually profile this ctDNA and okay, in the very comprehensive way, we are talking about profiling more than 500 genes at a time. So we can actually cut this long journey to become 7 or 8 days, basically. And this is not only doable in Western world, and we have shown that it is doable in Malaysia as well. So this is how the results will look like. Not only that it gives you, okay, the very comprehensive analysis, it can also, based on the mutation, to recommend the drug treatment that is available so that the oncologist can make a decision, and the patients can also make a decision based on what kind of cost that they can afford. So now, when it comes to cost, basically, I think a lot of people are very put off because of NGS and also the genomics and precision medicine always have the impression that it's very expensive. But the question that we should ask is that if we don't do that, your cost is going to be even more expensive. Why do I say that? Okay, for example, okay, the current practice in the single gene test or sequential test here, this is a study from Canada, basically. The cost of it is basically about 9,000 Canadian dollars compared to if you do a comprehensive gene profiling, the cost of it is only about $3,000, basically. So it's about 3 times more expensive, okay, and a lot of the costs are coming from because of delay of treatment. Right? So if we do not put up the upfront cost, the upfront cost might be slightly more expensive with NGS, but then it helps you, it delivers the value and help you to get the right treatment in the first instance. So, and of course, okay, there are also, whether you want to choose using a comprehensive or also a small panel, and our data shown that a comprehensive study, a comprehensive profiling can actually give you a 98% of the chance of identifying right drugs for tumors compared to a small panels which have only like about 63%. And finally, okay, to look at the cost itself, right? So if comparing the ctDNA versus tumor biopsy, so this is for lung cancer cases. So I just want to point to you is that the technical failure rate of lung cancer biopsy normally hovering about 15%, whereas with the cfDNA, so the failure rate is relatively low and below 5%. So a lot of the time, in fact, in US, cfDNA have been used as a first line when it's come to diagnosis as well. And cost, of course, okay, a lot of people also think that tumor biopsy will cost less, okay, because you don't have to do the deep sequencing, but if you include the procedure that is involved in the tumor biopsies, it actually even costs more, right? So you have to run the CT guider, and not also that the patients also have the risk of getting pneumothorax and so forth. And putting it up together, I hope that basically I have convinced you is that, well, liquid biopsy could be a very effective, cost-effective tool, especially when it comes to accessibility. Imagine that monitor of your cancer patients and also detection of our cancer patients doesn't have to come to the first-tier clinic. It can be done at the GP office, right, to monitor it. And also can be affordable as well in the sense that, well, it will cut down the cost in terms of surgery, okay, the tumor biopsy, and it will also cut down the cost if we detect the cancer early. The cost of managing early cancer are much, much less compared to a later stage. And finally, so the liquid biopsy, because it is a simple blood test, you can actually repeatedly monitor the patients to look at recurrence, to detect the cancer early, and it is also much easier to apply to a mass population for screening and also for high-risk group as well. And with that, so I would like to thank my group here from Broad Institute of Harvard and MIT, and also our group, research group here in AGTC, as well as from the International Medical University. And this is my contact, so I will be happy to take any questions. Thank you.
Thank you, Prof. Leong, for the insightful session. So we open for Q&A. Is there anyone with any burning questions to Prof. Leong? Yes.
Hi, Prof. Good morning.
Morning.
Good morning, everyone. My name is Faiza. I'm from Monash University. I'm working on gastric cancer. Prof, this is something new that I'm learning today. So I want to ask two questions. One, this ctDNA, when they are detected, how do you know whether it's different than, whether it's normal or not? That's one. And second one, if it is an early stage cancer, meaning they also show ctDNA, like because what I understand is from advanced stages. So can you explain more on that? Thank you.
Right. So the ctDNA basically we look at the DNA and we do the sequencing and look at mutations that are associated with cancers. So as we know, cancer is basically arrived from mutations. So when the tumor cells, when they start to grow, so they don't grow indefinitely. Some of the tumor cells will die as well, and then they proliferate. So when those tumor cells die, so some of this DNA will actually be shedded into the bloodstream, and this DNA will carry the hallmarks of the mutations of the cancer. And when we do the deep sequencing, we will be able to identify those mutations. In a normal individual, we shouldn't see any mutations in there. So that is how the ctDNA works. So when we see a mutations, then there's a high chance that the particular individual might have a cancer in any part of the body. And with the right algorithm and also the methylated signature, we can then actually pinpoint, okay, where the cancers might be coming from, whether it is from the gastric or whether it is from the colon, so that they can do a further confirmation test to actually find out whether it is it is there or not. Yeah.
Thank you, Doctor, for your question. Yeah. Anybody else from the floor with questions?
Yeah, Prof. Dr. Cairo here from HTA Kuantan. When you talk about liquid biopsy, does it mean just blood, or it just include saliva, urine, and other fluids?
Oh, okay. So for liquid biopsy, I meant blood samples, basically. In particular, okay, the plasma, basically. Most of the circulating tumor DNA and also cfDNA are actually in the plasma fraction. Yeah. Blood, not the saliva. Urine, there are some tests that people are start to developing, but we still under research and experimental stage.
Thank you, Doctor, for the question. Anyone else from the floor? Okay, so we'll close the Q&A for Prof. Leong. Thank you again,
Right.
Prof. Leong.
Thank you.
Yes. Next up,
I would now like to invite Dr. Vicky to present a small token of appreciation to Prof. Leong.